So this is section 1.2, day 2, solving inequalities again, but with a little bit different twist to it. So on number 6, you'll see that we have 2 inequalities, but they're separated. Last time, if we had 2 inequalities, they were put together. We have to pay attention to the word in the middle. If the word in the middle says and, we're looking for where the 2 inequalities overlap each other. But if it says or, we're looking for everything that is shaded. So let's take a look at number 6. We want to solve it, each part individually to start with. So we're going to distribute the 4. We have 4x minus 8 is less than or equal to 16. Then you're going to add the 8 and then divide by 4. So we end up with x is less than or equal to 6. Then we go over to the other side, subtract the 5. So we have x is greater than 7. Now we don't put them together like we did in part 1. Keep them separated. We're going to put both of those on a graph, making sure that your lowest value is on the left. So 6 has to go on the left, 7 has to go on the right. 6 has an equal to sign, so that's a closed circle. 7 doesn't, so it's an open circle. This says x is less than or equal to 6, so we're going to shade to the left. This says x is greater than 7, so we're going to shade to the right. And since the word in the middle was or, that tells us that our interval notation is going to represent everything that is shaded. So our interval notation starts down here. Remember the left side, we're always want the smallest value first, so that's going towards negative infinity, all the way to 6 with a closed circle, so that's a bracket. And then since we have another piece here, we're going to connect it with a U, meaning union. The 7 is an open circle, so we have a parentheses 7, comma, and it goes all the way to infinity, which is always a parenthesis. Okay, so we have our 2 inequalities, our graph, and our interval notation. Now, if the word in the middle said and, we wouldn't solve it any differently. This would be the same, this would be the same, our graph would be the same. But if we had the word and, our interval notation would be quite a bit different, because here's our actual answer. On and, we're looking for the overlap. Do these 2 lines overlap each other anywhere? Nope. So if the word in the middle said and, our answer would be no solution. Okay, quite a bit different than negative infinity to 6, 7 to infinity. So it's really important to pay attention to that word. All right, let's take a look at number 7. Notice on number 7, we do have an and. So we're looking for the overlap. But before we can get to that part, we have to solve each one and graph it. So let's start by solving. We're going to add 3. So we have 2x is greater than or equal to 0. Sometimes people think it's strange to get 0 in a problem. 0 is just a number. It's okay. So we divide by 2. 0 divided by 2 is still 0. All right, and then we're going to solve this one over here. Start by adding 2. Negative 4x is less than or equal to negative 12. Then we're going to divide both sides by negative 4. Since we're dividing by a negative, we have to switch our sign. Negative 12 divided by negative 4, negative divided by a negative is a positive. We're going to take those 2 answers and put them on our number line, making sure the lowest number goes first, biggest number comes next. They both are equal to, so they're both going to be closed circles. This says x is greater than or equal to 0. So that means I would shade all the way to the right. Now this one says x is greater than or equal to 3. So that means with the 3, I would also shade to the right. So looking at that a little bit differently, our 0 went from 0 to infinity, our 3 went from 3 to infinity. Since it says and, we're looking for where they overlap each other. Where are both of those lines present? Well, right here. We have the 0 line and the 3 line. So that's what we're going to write our interval notation with. So we're going to start at the 3. It has a closed circle, so that'll be a bracket, to infinity. Now, if the word had said or, remember this is our actual answer, but the word in the middle changes a lot. The inequalities don't change, the graph doesn't change, but it does change your interval notation. Or means everything. So if it had said or, we would want everything that's shaded, and we would have gone from 0 to infinity. Okay. All right, number 8, I want you to hit pause, try that one, and then come back and see if you got the right answer. All right, we're going to start by solving, so we're going to subtract 1. We have 5x is less than negative 5. Divide by 5. X is less than negative 1. All right, and then we are going to add 2 on this other side. 6x is greater than or equal to 12. Divide by 6. X is greater than or equal to 2. We'll put both of those values on our graph, making sure we put the lowest one on the left. The lowest one is negative 1 and has an open circle. 2 has a closed circle. It says x is less than negative 1, so that would be to the left. X is greater than or equal to 2, so that would be to the right. We look at our word says and. And means overlap. Where are these two overlapping each other? Nowhere. So our answer is no solution. Now remember, if it had been the word or, our answer would have been negative infinity to negative 1 parentheses union bracket 2 parentheses, infinity parentheses. So very different answers depending on that word in the middle. So gotta pay attention to that. All right, last one of these before we move on to talk about domain. Please try number 9. Solve it out. See if you can graph it and find the interval notation, and then come back and check your answer. All right, let's see. We have subtract negative 15 on both sides. So negative 7x is less than or equal to negative 21. Divide both sides by negative 7. Since we divided by a negative, we flipped the sign. Negative divided by negative is a positive. Add 3. So we have 6x is greater than negative 3. Divide by 6. X is greater than, we're going to reduce that fraction to negative 1/2. We want to put both of these numbers on the number line, but make sure you put your lowest one first. So even though you got 3 as your first answer, negative 1/2 has to go on your number line on the left. Lowest values are always on the left. It has an open circle there. This one has a closed circle. So it says x is less than or equal to negative 3, so we will have everything to the left. This says x is greater than negative 1, so that means everything to the right. So essentially we have shaded our entire number line from everything to the left and everything to the right. All right, our word is or, which means everything that's shaded. Since we have shaded the entire number line, we would say negative infinity to positive infinity for our answer. Now, if the word in the middle had been and, remember we'd be looking for where they overlapped, and they would overlap in the middle there. So we would say parentheses, negative 1/2, 3, bracket. All right, now let's switch gears. We're gonna work on finding domains, which also we do with interval notation. So that's why it goes with this inequality stuff that we've been talking about. So first of all, we need to think about when you have a fraction, what number cannot be in the denominator? Also, if you're ever watching these videos and get behind, remember you can always push pause. So to write all this stuff down, you can hit pause, get it written down, and then come back to it. All right, so if you have a fraction, what number cannot be in the denominator? Well, hopefully you know that that's 0. You can never divide by 0. If you put it in your calculator right now, 7 divided by 0, your calculator will give you an error message. So what we're trying to figure out is what value of x gives us 0. Once we figure out what value of x gives us 0, that number is bad. Okay, that's the one we want to exclude. So then our domain will be all the other numbers, except for that bad one. All right, so the best way, or the easiest way I think to find that out, is if you take a fraction, all you have to do is set the denominator equal to 0, because that will tell you what that bad number is. So if you solve, subtract 6 from both sides, we find out that when x is -6, it makes our denominator equal 0. That means -6 is that bad number. It makes our fraction not divisible, because we can't divide by 0. So if x can't be -6, that means it can be every other number. So we write every other number in interval notation like this. We start with -infinity, the lowest number we have. We go all the way up to -6, but we use a parenthesis, because remember, parenthesis means not included. Okay? Then we put a union, and we start at -6 and go all the way to positive infinity. So -infinity to -6, parenthesis, -6 to infinity. And that is the interval notation for the domain for that rational expression right there. All right, so see if you can try that on number 11. Solve to find out what number can't be in the domain, and then write a statement in interval notation for everything that can be in the domain. So we start by saying that it is equal to 0. So we're going to add 15 to the other side, divide by 3, and we find out that x is that bad number. So x cannot equal 5. If it equals 5, our denominator is 0 and we're toast. So now we write an interval notation, always starting with -infinity to 5, parenthesis, union, parenthesis, 5 to positive infinity. So this is telling us every number except for 5 is okay. Same kind of thing happens when we have radicals. Radicals also have a certain value that cannot exist under the radical. 0 actually can, but negative numbers cannot. Okay, we cannot have negative numbers under the radical. So that means all the numbers that are okay have to be greater than or equal to 0. We can't have anything less than 0 in a radical. So to figure out what the bad numbers are, we take our radicand, so this part that's under the radical, and set it greater than or equal to 0. Solve for x. So we find out that x has to be greater than or equal to -5 in order for this radical to be true. Okay, so x greater than or equal to -5, you can see that correlates to what we were doing with the inequalities. -5 on a number line, closed circle because there's an equal to, greater than goes to the right. So interval notation, we would have bracket, -5 to infinity. And you don't necessarily have to draw the graph. I'm just showing you how it connects to what we were talking about with those inequalities earlier. All right, same thing on number 13. Go ahead and try that. Start by taking the radicand, set it greater than or equal to 0, solve it, and then translate it into interval notation. hit pause and then come back and check. You should have 24 minus 6x is going to be greater than or equal to 0. It has to be for it to be true. Subtract 24 to the other side. Divide by -6, so we're going to switch the sign. So we end up with x is less than or equal to 4. Oops, sorry. So interval notation, you can draw a picture of the graph, but you don't have to. If you know that x is less than, I think I might have said greater than earlier, sorry, less than or equal to 4, knows that we're going to have all the numbers from -infinity up to 4 are going to be okay. These are the correct answer, correct values for our domain. Anything outside of that would not be in the domain. They would make our radical false. Okay, so that is all for section 1.2, part 2.